And this is on page 109. Okay, number 22. All right, so this is a football player. Takes the ball from the line of scrimmage, runs backward for 10 yards. Runs sideways parallel to the line of scrimmage for 15 yards. And I guess I'll go this way since I give myself enough room. Throws a 50-yard forward pass straight down the field. What is the magnitude of the displacement? We ought to be able to just do this without any resolution. Should we not?
Because it's frightening.
Well, I guess we do need components, don't we?
Well,
Yeah, we kind of do. All right, there's the resultant.
I mean, I did components, but I just didn't really calculate them because I just wrote down like what they were
Yeah.
supposed to be.
Well, I was just thinking that you got this side is 15, right? That's 15, isn't it?
Mhm.
And then this would be what? 40? There's your right angle. So you could just put that in the diagram theorem.
Yeah.
Yeah,
Yeah, but what?
I think it'd be easier to go through all of them because like,
To review?
yeah.
Okay, let's do it.
It'd be easier to go through all of it.
Let's just go through all of it. Because obviously I'm not going to give you one that easy on the test. I mean, I might give you one that easy on the test, but that won't be the only one, right? Okay, all
Actually,
right.
well, bunch of the easy ones, you just not even late.
If I give you everything easy, you would be in your first semester. You would be in your first semester of physics in college, going, OMG.
But
What's this?
All right, so let's call that D1, D2, D3. Okay, so D1x is going to be what? D1 cosine theta. So that's 10 yards cosine
of 180.
of 180. Good.
Oh, it's negative 10 yards.
Negative 10.
Yeah. There's not really much calculating to go through
I
this.
know, I'm just thinking, I'm not thinking. All right, so D1y is 10 sine 180, which would be,
0.
okay. D2x is going to be 15 cosine. Okay, straight down is what angle?
270.
Good, because remember from yesterday, if we just make it a practice, 0 degrees, 90, 180, 270. That will avoid possible confusion.
So,
And then y. What's it gonna be?
Negative 15.
And I'm not putting my units. Shame on me. D3x 50 cosine of what?
0.
Which equals,
50 yards.
yeah. And D3y,
50 yards times 0 equals 0 yards.
DX total?
40
What we got? DX total, we got -10,
and 50.
0, and
50.
+50.
So it's 40.
I don't have 6 either. So dy is 0 minus 15 plus 0. Right? Okay, so it only wants magnitude. What does that mean we do not have to do?
Tangent.
Okay, so this is going to be your x total squared plus your y total squared.
Oh, it just wants.
Did you try to get the angle?
I already got the
You already got
angle.
the angle. We can review it.
That was, I was asked for magnitude. I
Well,
was
we
just like,
can-
oh, I'm just gonna do a vector anyway.
and we can just go ahead and do that just to get an
Scalars
idea.
for chumps.
Yeah. So what's this come up to be?
Yeah, 42.7.
2.7.
42.7.
42.7. How many sig figs?
No,
Yeah. Okay. Yeah, this problem only asks for magnitude, so that's as far as you have to go. But to review this direction stuff, let's go ahead and do that. All right, so for the direction, if and that's so loud. I need to learn how to lighter touch on the chemistry video this morning. It's like pow, pow, pow. I was like, jeez. I need to, I was going, chur. All right, that's the angle we're looking for.
Yeah.
Right? Okay. So,
Oh yeah.
okay, so tangent is opposite over adjacent, correct? Okay, so that's going to be vertical over horizontal here. Do you see that? Right? Okay, so I'm out of space.
Just extend the page.
Alright, so the angle is going to be y over x. So that's negative 15.
I got 26.
36.
Yeah.
Oh, well.
Okay, so what does that mean though? You know, that's below the x-axis, right? Okay. Well, I was glad that they did not ask for direction, because how would you say this on a football field? Would it be 20.6 degrees to the right of the scrimmage line, or down to the right of downfield? You have to,
in respect to the scrimmage line?
yeah, or you could say, well, actually,
And
this is the scrimmage line, isn't it? Right here?
And it never specified on direction.
And it never, yeah, it never
Maybe it's a
specified.
problem.
Yeah, so you can't, all we know is this is forward and this was back. That's all it said.
That's a scrimmage one, isn't it? Up there,
The 15,
up there, right?
I don't know, because I don't play football.
Yeah. But with the opposite side of the arrow on the 10-yard one.
But I'm sure, okay. But yeah, if you had to, you could say with respect to downfield or something like that. To the right of downfield.
Yeah.
I don't know scrimmage lines. So I know what I read in the problem, and that's it. But yeah, you've got to relate it back to your frame of reference, and that's where you kind of get a tip from the question prompt.
They got almost ran them down.
Yeah.
Yeah, I don't even know what a scrimmage line is.
It's where all the linemen are, all the back people.
Where the ball's lined up at?
Where the ball is.
That's the line right across
Where the
the.
ball is for the quarterback.
Have you ever watched
Oh,
football like,
yeah.
on TV? Like the little imaginary line right there?
Yeah.
Like between- Yeah, that's the line of scrimmage.
Okay, that's where they do your stuff.
Yeah, pretty much.
That's where they do their stuff.
Yeah.
If you pass that line before the ball's knocked, it's offside.
Okay, all right. I learned something today. Thank you. All right, projectiles launched horizontally.
Throw something.
I felt like throwing something this week.
Yeah. Understandable.
Let's look at number 27.
Okay.
No, wait, no, that's, yeah, because we need to do some qualitative stuff too, not just math. All right, 27. A dart is fired horizontally from a dart gun, and another dart is dropped simultaneously from the same height. If air resistance can be neglected, which dart hits the ground first? Same time.
Yeah.
Because vertical and horizontal are independent of each other, right? So really 28, 29, and 30, they're basically addressing the same concept. You can read those to get comfortable with the way the questions are worded. I recommend you do that. Let's take a look at 33 on the next page. I think. Let me read it first.
A spy in a speedboat is being chased on rivers by government officials.
So it's like the gazelle and cheetah problem.
That's what I'm thinking. Let's see, just as the official's boat pulls up next to the spy's boat, both boats reach the edge of a 5-meter waterfall. If the spy's speed is 15 meters per second and the official's is 26 meters per second, how far apart will the two vessels be when they land below the waterfall?
Great question. That's all it's saying.
I didn't know what he said. I was like,
Good question.
Well,
I don't know how to go about like this.
yeah.
Well, let's think about it. This is 33 on page 110, see?
it took me a minute. I was like,
You forget that you're recording.
Okay. So let's draw it out. Okay. Waterfall, right?
Yeah.
All right. What's the delta y of that waterfall?
5? Didn't it say 5 something?
Yep.
5 meter.
Okay, so the delta y of these two boats are going to be 5 meters. Okay, start there. Okay, these boats, this boat has a horizontal velocity of, let's do the spy first, what, 15 meters per second?
How are you going to draw the officials because they're like side by side?
That's what I'm saying, I'll have to get creative here.
Draw
We have to erase a little bit. Okay, so who can draw the trajectory of the 007's boat? Somebody come up here and do that. Nobody?
I'll try. No
Just,
guarantee.
I mean, just draw, what's the trajectory?
It's like
the
the
Yeah.
thing that you always.
Yeah, and it's always the shape of a parabola. There's just some qualitative questions for tomorrow. The path of a, yeah, the path of a projectile is its trajectory.
Oh, beautiful.
A trajectory is always the shape of a parabola.
Is this ignoring air resistance also?
Yes.
It is? Okay.
We will always ignore air
Oh, they're like at
resistance.
the same time. Yeah. If they draw them at the same time.
Well, it says they're side by side when they go off the cliff.
And
So yeah, they would hit the ground at the same time,
Okay.
asking how far apart they'll be.
And, okay, so this is the spy. And let's make this the,
Make them taller.
Make the officials boat taller. Spy boat's gotta be little to spy. Oh, beautiful.
shorter than official. All right, it has a horizontal speed of 26. So let's look at the trajectory for this one. Good, why is it?
Because it's going fast.
It's going faster. It's going faster, which means it's going to go out further, right? So what is it that we need to find?
We need to find how far apart they're gonna be.
Which means
Where they
we
land.
need,
A delta X.
we need a delta X here, and we need a delta X here,
There.
and get the difference between them.
Yeah.
Good. All right, so
How long that thing will be in the air.
side. We know that delta X is what? V sub X times delta T. Looking at those equations for launch horizontally, is that not correct?
Yes.
So we need time.
Yes.
Okay, so how are we gonna find the time?
One would be
Using,
the square root
Yeah.
of 2 delta Y over G.
Get it, girl.
oh yeah.
Did we not have a negative in there somewhere?
Wait, what?
Did we not have a negative in there somewhere?
No.
I feel like a negative will make it
Okay.
complicated.
This one is locked in the vault.
Oh, why? Why?
The
Yeah,
one-
that's negative and that's negative.
Oh, yeah, because between the
The
lines.
exertion of
Right.
gravity is.
Is the big story.
Okay, so delta Y is a negative 5 meters. And G,
Negative 9.81 meters per second squared. You know.
okay, so what's the time?
Hold on, just.
Let me do a calculation.
Somebody want to come write it up here?
uh,
Okay.
Oh my god. I got my answer, but I don't know if it's right.
What'd you get?
1.0096 dot dot dot.
We got
Yeah,
1.009,
I got
Yeah.
1.009 also.
and we're dealing with, two Sigfids here, so that'd be 1.0, right? Andy, you good with this so far?
Is it just 2 6
I think so.
Yeah.
That's just one second one.
Yeah. Okay, are we done?
No, that's
No.
what it is. Look,
Still got a lot of stuff to do. We gotta plug it in here. Okay, so delta X times 5 is going to be, velocity is
15.
15.
Oh, we should have those sequence
Well,
because this wasn't the final answer.
yeah, but it's still, it's like 1.009, so I think we'll be, but you're right. You should always carry out extra sig figs until you get to the final answer. Every time you round, it introduces a little bit of error, but here it would round to what? 1.01, which would still be 1.0. I think we'll be okay on this one.
Yeah.
But it makes y'all, just to show y'all, we'll do that. All right, seconds are going to cancel.
15.135.
So to 2 sig figs,
15.
delta x to the pi is 15 meters, right? Okay, now we need to do the
Well,
top.
well, the
That's
clock would
15
just be
meters, yeah, it's
26,
26,
because the
because-
time's gonna be the same.
That is, yeah,
Yeah.
good.
So delta x top equals 26. And then so the cop is 11 meters.
Are we sure?
Yeah,
Yeah, they're right.
Yeah.
They're right. Because they both have the same delta y and the same g.
Yeah.
It's going to be the same time for both of them.
So the difference is 11 meters.
See what I mean? They are right.
so the clock's gonna be 11 meters and
And we
times
can prove
pi.
it.
Where's the pi?
But
Okay,
then it
right
turns
here,
against
like I
G.
said, that it's the same delta y and the same g. It's going to be the same time.
And then I don't know where the
Yeah,
spot
but
is, the water breaks.
The other thing I'm confused about is that why is it 5 meters and it's like acceleration doesn't make sense to me for some reason because it's like cause it's 9.81 meters per second squared and it's negative 5 meters. So shouldn't it be in the air less time?
Oh, I see what you're saying.
No, right. So
I don't
it
know.
should be like half a second, maybe. Not even
I don't know what to
second.
tell you though. I mean, without taking some time with it.
Yeah.
I see what you're saying. That if they're falling for one, but that would be their speed. Yeah, I see what you're saying, but that's good. That's a good question. Okay, so they are going to be, or 26 meters and 15 meters. What, they're going to be 11 meters apart? The two boats? So that means the cop's going to hurry up and turn around and go back after him? Okay.
It'd be hard to turn around going at 27.
Yeah,
seconds.
Dustin had a comment that if it's falling 5 meters, and its initial speed is 0, and then it falls for 1 second, you're saying, why is it not a half second?
Why is it not less than 1 second?
That's why, but I'm kind of stumped on why that's there.
Maybe they
And
don't
since-
want it to be less than 1 second.
And since, clock's ticking, we can't spend a lot of time on it right at the moment, but
Well, wouldn't the negative 9.1 only affect it after the first second? Like, doesn't that only?
no, it starts affecting it as soon as it leaves
Okay. So,
and becomes a projectile.
okay, so it's just
Um,
boom, 9.1.
I don't know, it's delta y equals 1/2 g delta t squared. I would have to read about it somewhere. It's a good question. I don't have an answer for you right now. Sorry. but that is a very good question. Maybe I can work on that tomorrow. Now, with the remaining time we have left, we need to look at launched at an angle.
What if we just found a flaw in the,
We wouldn't get rich.
will we get rich? They'd be like, oh, okay,
Sorry,
like a racist
no,
fix it.
we're not going to get rich.
Will we get our names in like the children's book or something?
I don't know.
Like just put a name somewhere.
Page 10,
We're going way back.
page 101. I have asked you to work practice E. Practice E is due tomorrow.
When?
I asked you Friday.
Oh,
I asked you Friday.
Well, before that, could you see these, any of us have had it yet?
Yeah. I will give you the answers. I told you to not do number 2. I recommend that you read sample problem E very carefully. That'll help. Practice 3E, numbers 1, 3, and 4. Read sample E first. The answers, number 1, the answer is yes. He will make it to the other roof.
We worked number
Yeah.
We set up number 1.
Yeah, we set it up, we didn't finish it. Yes, the stuntman's gonna make it to the other roof. And his delta Y is negative 2.3 meters. Number 3, the time of the baseball is 2 seconds. And it's delta Y. How high did it travel before it got caught? 4.8 meters. Number 4, what is the speed of the salmon? 6.2 meters per second. Okay, let's look at number 34. And this is on back to page 110 again. A shell is fired from the ground with an initial speed. I'm on page 110.
How do we go from 1 second?
Okay, shell is fired with the initial speed of, that would be what, 1700? With 3 sigfids. I hate writing scientific notation. 5 times the speed of sound at an angle of 55 degrees. And that's again 3 sigfids. Y'all have to remember 3 sigfids. Find the range. What is range?
Like the highest and the low line.
Yeah, we will.
Range is delta x. Like on a graph in math class, range is how far out.
So what's the distance from the starting point to the end point?
Yeah, how far out it's going to go.
okay, so it's just like the final vector, like in.
No, we have to treat them independently.
So it's not like the resultant. Like, could we call it that though?
It says the shell's horizontal range. I would just call it delta x.
Okay.
And then the amount of time that it's in motion. All right. So how are we going to find its range, its horizontal range? Well, we need the horizontal component of what? Velocity, don't we?
Yes.
Yeah, and you can take a look at these equations, but you've got what? You've got delta x equals v initial cosine theta delta t. That means we gotta find what first? Time. So how are we gonna find time?
This one.
Mm-hmm.
When it says 1,700 meters per second, is that its vertical or horizontal velocity or both?
Resultant. Is that what you were saying? I thought you were talking about range. This is the resultant. This is vertical and horizontal combined. I know what we could do to find time. Y'all remember we talked about when we were working on free fall? We talked about what does something have to do before it changes direction in the air? It comes to a stop. So if we take this parabola and we divide it in half, how do we do that? Yeah, we can do that.
What are we doing?
I'm thinking vertically, not horizontally, vertically. That bullet is what going to go up, and then it's going to go down. Before, remember, vertically, it's just free fall. It's going up and then it's coming down. So at the middle of the flight,
It's zero.
its speed is 0. So we can call that v sub y final for this half of the trajectory. It's only for half of it, right? Because then it's going to start speeding up in the downward direction, right? So if we do that, we could solve for time with v sub y final equals v initial sine theta. That's vertical component of velocity plus g delta t. These are the equations on page 99 that I asked you to write in your cards. If we're only going to treat half of the trajectory, this would be the time for half. So then we would have to double it when we go to figure the whole horizontal range, right?
Mm-hmm.
Okay, but if we're looking at just half, what would this final vertical velocity be?
Zero.
So 0 equals 1,700 sine 55 plus negative 9.81 delta t. So we solved it. Alright, so we get what? 0 equals, this term becomes 1392, 1393. We got 3 sig figs. Remember, I told y'all remember 3 sig figs. So if we call it 1393, that'll be an extra sig fig. And that's meters per second.
So what is our final? We're trying to find it right now.
We're trying to find just this for half. Okay, and then we've got what? That is added to a negative 9.81 delta t. So we move this term over here, and that becomes negative 1393 equals negative 9.81 delta t. Divide, right? Divide both sides by negative 9.81. And we get delta t. $141.95 seconds. But remember, that's only for half.
So you double it.
So, yeah, because remember we're saying, okay, if Vy final is 0, the bullet's going to be right here. Now it's going to start coming down. This is the same time as this. So we need to double that time. And that would give us what, 284 seconds? Now we can find delta x. Okay, let me just work over here because we're running out of space. Delta x equals v initial cosine theta times delta t. They put that in parentheses just to keep it from getting confusing. Okay, so that'd be what, 1700 cosine 55 times that 284. Do y'all see why I don't care for the smart board now?
Yeah.
Now if they give me one that size, they ain't gonna do that.
Do they have something like those?
Nope. I mean, I'm sure Smart Company does.
Usually do giant dry erase board, or usually only dry erase walls.
I think it's 12 pins.
All right, y'all, I get 27,692.7.
Dang. What?
Well, it's a bullet moving at 1,700 meters per second.
You have a point.
Okay, we got 3 sig bits. What are we gonna round that to? I hate having back to y'all. Hate it. 3 sig bits.
Six figs.
277.
So you got 277,000.
Yeah, you can't forget that.
Right, I was gonna put this on consideration really quickly.
Oh, you can do that too. And what is the unit? That's a second.
Meters.
So that's another little trick you can use. Is it's called symmetry.
So, if it's going at 1,700 meters per second and then it hits 0, wouldn't it be 1,700 meters per second before it hits the ground on that side? Because it picks back up the speed.
But that 1,700 meters per second is the resultant of horizontal and vertical.
Oh, yeah, and vertical. But what, I mean, okay, now I'm just confusing myself.
Yeah, quit. Okay, so that's it. So, let's just do a quick rundown of what I'm going to ask y'all tomorrow. Chapter 3 test, Wednesday, tomorrow. All right, section 1, I'm going to ask you to add vectors with ruler and protractor, like on the quiz. That is called graphical method. And I don't know what the sections are anymore. It all runs together. But then I'm going to ask you to add vectors. It's called analytical method in this book. It's sine, cosine, Pythagorean theorem. And tangent. Resolve vectors. into X and Y components, horizontal and vertical. Get the vector stone. Projectiles horizontal launch, and projectiles launched at an angle. I will not ask anything about section 4. So if I were to give you advice, I would go back and reread these sample problems in sections 1 through 3, section reviews. Let's look at some of these qualitative questions.
Oh, sorry.
Go to page 108. Are you here for class?
Yeah,
You
I didn't
just
know
have to
it's not
see.
it right.
Y'all, flip back over to page 108. These review and conceptual questions are really good to get you thinking about the concepts. Let's pick out a couple before you leave. Like page 108. Number 1, number 2. If two vectors have unequal magnitude, can their sum ever be 0?
No, it won't
No.
cancel out.
They have to be equal and opposite for them to cancel. Remember, magnitude is the size, the number, right? What about number 18? If vector A plus vector B equals 0, what can you say about the components?
They're both equal.
They're equal. Okay, and then like 27 through 30 are good questions. So to get you into the mindset of the qualitative stuff, I would look at those concept questions and review questions. I will be here at 7:30 in the morning if you want to come in and study. If you want to review, ask questions, I'll be here. Y'all have a good afternoon. I do